Okay, this is chapter 9, number 56. We have two billiard balls. They have the same mass. Okay, mass A equals mass B. So if mass B is going horizontally, hits mass A going up the y-axis, and they say that mass B will go straight up the y-axis. They question which way is mass A going. Well, I'm saying it's going to go in the x-axis. It doesn't, but we'll see. It really should, since it's the same mass. Okay. Now, the conservation of momentum formula is really with vectors. So the vectors of the conservation of momentum conserved. So keeping in mind direction, let's start with x direction for all of the vectors, all of the masses. And that would be, so momentum of A in the plus momentum of B in the x direction equals the moment after A in the x direction plus momentum B the x direction after. Okay. So in the x direction B is going, but not A. So this is 0. A is in the y direction. Afterwards, A is going in the x direction, B isn't. We know that B is not going in the direction, so that's 0. So this at least has some x component. But since, anyway, let's finish this off. So, mass of B, Vx, Vb equals mass of A, Va prime. And they are the same, so really what we're saying is that Va prime equals exactly the same thing, 3.7 meters per second. Okay, that solves that one. In the y direction, momentum of y in the y direction of the A ball, and we have momentum of the B ball in the y direction will equal momentum of the A ball after in the y direction plus the momentum of the B ball in the y direction after the collision. Now here the B ball is not moving in the y direction. It's moving in the x direction. That goes to 0. The ball is y direction. It's after the collision. It's moving the x direction, so that's 0. What's left over is an A V VA equals plus MB VB the collision. So, oh, I wrote that funny. Let's get rid of this and put it in its proper place. Goes up here. Okay. So what we're saying is that since these cancel out or divide out, VB prime equals what VA was in the beginning, which is 2.0. Okay.